So if you go through this NFPA 13 document, that is standard for the installation of sprinkler system. Okay, so this document we will refer
Okay.
for our calculation purpose. If you go through down,
I
okay,
can't see your screen now.
okay, let me share my screen. I hope you can visible, right?
Yes, yes.
Okay, now if you go through the document, there are important criteria, design criteria.
Hmm.
Okay, the classification of hazard is very important. You have to decide whether it is light hazard, ordinary hazard group 1, or ordinary hazard group 2, extra hazard group 1. That we have to decide depends upon the fire load. Remember what I said before?
Okay. Yeah.
Okay, then after that, if you go further down, here you can see the system protection area limitation. Can you see that light hazard maximum 4830 meter square? So that means whenever you have a zone control valve, that will be designed based on that. Okay. Also, you remember we have a UAE fire code.
Hmm.
Okay, let me open that UAE fire code as well. So here you can see the light hazard 52,000 square feet and in meter square 4830. Okay, in UAE fire code, if you go to fire protection system, okay, here you can see the zone control valve, section or floor zone control valve. Remember last time I told you that zone control valve will
Yeah,
be
yeah.
installed
Yes.
every floor to identify which floor is a fire. So you can
Which
see
is
that
on? Yeah.
sectional or floor zone control valve assembly installed where the tapping is taken from the sprinkler riser for each floor in multi-story building. Okay, the
Okay. Yeah.
high rise building shall be provided with a motorized zone control valve supervised by a zone control valve for annunciation and manual operation by civil defense to control, activate or deactivate the desired floor sprinkler. Okay, the zone control valve control panel shall be located in the fire command room, FCC room. Zone control valve have a supervised butterfly valve fitted with indicator showing open and close position. That is why we use O, S and Y valve. Okay, so that is
Okay.
it's nothing but butterfly valve, but you can see the position. Okay, the zone control valve have a water flow alarm switch having paddle type water flow detector suitable for the size of the pipe in which it is installed shall be fixed after the butterfly valve on the main supply pipe and before any sprinkler connection is taken off. So the zone control valve shall have an inspector test and drain pipe connection having not less than 25 mm diameter shall be installed on downstream side of the flow switch. Clear. So this is the zone
Yeah.
control valve.
Okay.
You can see all the types. Before that,
But
if you
this
see,
is butterfly valve, right? Not OS and Y gate valve.
no, it is a OS and a gate valve only. You can see this is the
The
OS and a
picture
gate
is
valve.
no.
Yeah, that
This
is
is
okay.
butterfly.
But actually it is installed OS and a valve. The purpose of the OS and a valve is you can see by manual. You don't see, for example, butterfly valve. You cannot see whether it is closed or open, right?
Yes.
Unless
Yes.
you check and test. But OS and a valve, by seeing this one, you can identify. Okay, whether it is open or closed. Okay, so that is the
Yeah.
purpose. Okay. Now I will come back to the alarm check valve. Okay, alarm check valve. Can you see that light hazard 4831 square meter, ordinary hazard 4831 square meter, ordinary hazard. So an alarm check valve assembly shall be installed in each sprinkler system riser as the maximum sprinkler protection zone area limitation as per table 9.7.17.2. Okay, so this is the 9.7 and this is the 17 and this is the 2. So you can see that light hazard 4831 square meter. If you have a light hazard, so alarm check valve complete with the water motor alarm gang, electric alarm pressure switch, pressure gauge. So the maximum sprinkler zone limitation is 4831 square meter. So whenever you install one alarm check valve, is connected with the 4831 square meter.
One
Clear?
alarm equal for 4831 square meter.
Square
Okay.
meter, yes, yes. So that is the calculation purpose. Okay. Now if I go further in the NFPA code, the same thing is given here as well. So whatever UAE code extracted from NFPA, keep in mind. Okay.
Okay.
You can see that the size of fire mains. So the minimum, the no pipe is smaller than 6 inch. Okay. So every pipe will be 150 pipe, riser pipe. So that is the size.
Okay. Size should be minimum 6 inches.
6 inch. So that is why whenever you see the riser, we will be using 6 inch
Mm-mm.
or greater than. Okay, not nothing lesser than. Okay,
Okay.
unless you prove by hydraulic calculation.
Mm-mm.
Okay, and if you go further down, okay, here you can see the sprinkler discharge characteristics. Remember the K factor what we are using is 5.6.
Mm-mm.
Okay, and the
5.6.
percentage of discharge will be 100 percentage. Okay,
Okay. Mm-mm.
and the K factor will be 5.6 here. Okay,
Okay. 5.6.
yeah.
It's not
Here you
for
can
all sprinkler, right?
no, it is for all the sprinkler. As of now, we keep it in that. Then we will
Hello.
discuss different classification. Okay,
Mm-mm.
clear?
Okay.
Okay.
Yeah.
Now, if you go here, you have a different type of sprinkler classification. Depends upon the temperature rating where you use. Okay. It doesn't mean that you have to use the same sprinkler for different application. Different temperature, you have a different sprinkler. Even outdoor, you have a different sprinkler. Indoor, you have a
Mm.
different sprinkler. Okay. So it
Mm-mm.
depends upon the temperatures.
Okay. Mm.
Yeah, can you see that? For light hazard occupancies, sprinkler having a nominal K factor smaller than 5.6 shall be permitted subject to the following restrictions. So always sprinkler is with the 5.6. If you have a less than 5.6, you have some reasons here. The system shall be hydraulically calculated. Sprinkler with nominal K factor or less than 5.6 shall be installed only in wet pipe sprinkler system or in accordance with the limitation of 9.4.4.3. That is this one. Sprinkler with nominal K factor or less than 5.6 shall be permitted to be installed in conference with the 19.4.2. So this particular one against exposures. Okay. So as of now, keep in mind that it is 5.6 for our
Okay.
calculation
This
purpose.
K factor meaning what, sir? K
No,
factor.
the holes actually. It talk about holes and the pressure. You will come back to that. Okay.
Mm-mm.
You will see that one. It is about discharge. How much you are going to discharge. Okay,
Means
so
the
the
water
discharge will
flow,
be
right?
100. Yeah, water flow rate. Yeah. Okay. Now
Mm-mm.
I will come back to you. You will slowly will understand. So here you can see the protection area of the sprinkler shall be established by multiplying the S and dimension by the L dimension as follows. So whenever you talk A is equal to S by L. Clear?
Okay. Area of
Okay.
coverage.
Area. Yeah. Area of the coverage is nothing but S by L.
Okay. Mm-mm.
Okay. S is the dimension and L is also dimension. Okay.
Okay. Dimension means which dimension?
It's a
Maybe X, Y,
distance X Y X
X,
Y.
Y, X, Y.
Okay. So
Mm.
you can see, you can read this one. What is the maximum distance from the wall? What is the minimum distance from the wall? What is the maximum distance between sprinkler? So you can see that the
Mm.
maximum protection area of coverage, the maximum allowable protection area of the coverage for a sprinkler shall be in accordance with the value indicated in the section of each type of sprinkler. The maximum coverage area of any sprinkler shall not exceed 400 square feet, 37 meter square. Okay.
400 feet square. Okay.
Okay, the sprinkler spacing maximum distance between sprinkler. The maximum distance permitted between sprinkler shall be based on the center line distance between adjacent sprinkler. The maximum distance shall be measured along with the slope of the ceiling. The maximum distance permitted between sprinkler shall comply with value indicated in the applicable section for each type or style of sprinkler. Okay, the maximum distance from the wall, minimum distance from the wall. minimum distance between sprinkler. Okay, so this is the calculation method. Okay, so here you can see that the protection area is 130 feet square.
Okay.
So you can see that the maximum area of coverage of any sprinkler, one sprinkler, I'm talking about one sprinkler, should not exceed 37 meters square. Okay, so this is the code, but if you go to the ordinary hazard, it will be only 12 meters square.
Okay.
Okay, if you talk about light hazard, it can cover up to 20 meters square. Maximum protection area, 20 meters square.
This 36 for what? 36 for
What is 36? 36 or 37?
no, just 36 square meter. 37 for
Where you have seen 36?
no 37. 37.
37 is the maximum area of coverage. If you talk about one sprinkler, it will be maximum coverage. That is 37 meters square. But it will change depends upon the classification. Okay, if you are going with the light hazard, you can cover 20 meters square.
Okay.
Okay, and if you go with the ordinary hazard, you can cover up to 12 meters square.
Okay.
Okay, if you go with extra hazard, you can see the protection area is 8.4.
Okay.
Okay, so you can see the difference. If it is a light hazard, you can cover 20 square meter, and if it is ordinary hazard, you can cover 12 square meter, and if it is extra hazard, you can cover 8.4 square meter. So these three you note down. Okay, very important.
This page number 15.
Page number 13. Yeah, page number 13. Okay.
Okay.
So if you go further, there will be density curve. Yeah. Can you see the design approaches? Okay. So this particular, just note down chapter 19. Okay. So this is the design approaches. Okay. So here you can see that water supply requirement for pipe schedule sprinkler system. Okay. You can see that the light hazard, you can see the duration 30 to 60 minutes, right?
Yeah.
So that means you should have a you have to design the system for 30 to 60 minutes for the light hazard. If it is ordinary hazard, you have to design for 60 to 90 minutes. Okay. And if it is for extra hazard, it will be 90 to 120 minutes. Okay. So that is not given here, but this is the one. Okay. So this one where it will helpful for your calculation, it will calculate for your water tank sizing, as I said last time.
Yeah.
So the water tank sizing is based on the flow multiplied by duration. That will give you the water tank capacity. So what is the flow? Assume that it is 1000 GPM. For example, we will come to. I will explain you how we calculate 1000 GPM. Okay, but as of now, 1000 GPM is the calculation. What you calculated multiplied by 60 GPM, 60 minutes.
Yeah.
So it will give you gallon by minute multiplied by minutes. Minutes will cancel, and you will get gallon, total gallon. So that will give you your water tank calculation. Okay.
Okay.
Okay. So the design approach, you can also read that one. So you can see that general chapter number 19 shall be utilized for design approaches. This chapter is used for design approaches. The requirement of section 19.2 shall apply to all sprinkler system unless modified to a section chapter 19 or 20. Okay. Now you can see the water demand. The water demand requirement shall be determined from the following: occupancy hazard, fire control approach, and the special design approach of chapter 19. Storage design approach of chapter 20. Okay. And special occupancy approach of chapter 26. So here what it supplies, the tank shall be sized to supply the equipment that they serve. Okay, pump shall be utilized to supply the equipment that they serve. So this is just general note. Okay, and they are talking about hose, they are talking about occupancy, hazard, residual pressure, everything. Okay.
Residual pressure means
the pressure after the sprinkler discharge.
Okay. Means the water pressure when
After,
the sprinkler
see, for
breaks.
example, when the water discharge, it should discharge at that pressure. Okay.
Okay.
So
Okay.
that means whenever you calculate the pressure rating, you should add residual pressure plus sprinkler head pressure plus piping and fitting pressure, valve pressure that is designed for your pump head.
That means when the sprinkler breaks, the water will flow
Should
on this pressure, right?
should pressure at the, yeah, that is a residual pressure. So you can see that
Okay.
reservoir pressure requirement, okay, of shall met at the following sprinkler. Okay, it's fine. Okay. Okay, now you can see the design density. So
Hmm.
different hazard.
Yeah. Okay. Hmm.
Okay. So now we will go very simple. Say for example, if you go to a light hazard. Okay, in the light hazard, what you get? 0.1, right?
Yeah. Hmm.
Okay, at a minimum of 1500
GPM.
area of the
Hmm.
spring area of the sprinkler area of sprinkler operation 1500, and what is the density? It is 0.1 density GPM per square feet. Can you note down whatever I'm saying? Density
Yeah.
area of the sprinkler operation will be 15,000 square meter.
Density 0.1.
Yeah, density means 0.1 for light hazard, 0.15 for ordinary hazard 1, and zero point 0.2 for ordinary hazard 2, and zero point 0.3 for extra hazard 1, and zero point 0.4 for extra hazard 2. So it's given here directly. You can see that lining directly. Okay. And when you start with the
Okay.
light hazard, ordinary 1 hazard, ordinary 2 hazard, the minimum area of the sprinkler operation will be 1500. We are calculating for the minimum.
Minimum area of sprinkler
Sprinkler
operation.
operation will be 1500 square feet.
Okay.
It's clear?
Yeah. Clear.
Okay. Next one. So here what you will do, if you multiply by this one plus this one area of the operation, so you will get total gallon, right?
Okay.
So can you multiply by 1500 multiply by 0.1?
Yeah. 150.
Yeah, so 150 GPM.
150 GPM. Yeah. Yeah. Okay. 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 Mm-mm.
Okay, so that is the density. Okay, density per square feet.
Okay. Area into density. Area into density will be GPM.
Yeah, area into
Flow
density will
rate.
be, yes,
Flow
GPM.
rate. Flow. Mm.
Yeah. Okay, so you got that one, right?
Okay.
Okay,
For
next
example, if
one.
we have light hazard, and first we need to calculate the area of. For
Yeah, yeah.
example,
Area
if
of
I
the
have.
sprinkler operation will be this much, 1500 square feet. Okay,
Mm-mm.
and the
Okay.
density
If
will
it
be
is more,
GPM.
we have to divide it into zone wise up to maximum 5,000, like that, or what?
Yeah, yeah, yeah. That I will explain you step by step. Okay. Now you
Mm-mm.
just note down whatever the important steps, sir. Then slowly you can able to follow that one. Okay.
Mm. Okay.
Yeah. Now let me go through another steps. So now if you go here, okay. Remember just now we calculate the light assault. Okay, remember we calculate here design approach. Area is nothing but S and L. Okay, so that means what is the
Okay.
area? Area you can see, for example, for the I will just consider for ordinary assault. Okay, we will go through based on ordinary assault. Okay,
Mm.
and area is how much? How much I said? 1500 square feet, right?
1,500 square feet. Yeah.
Okay, can you divide by 130?
1,500 divided by 130. 11.538.
11 point
130 means what? Okay,
130 is a
square feet.
square feet
Yeah.
protection area.
11.53.
So it is nothing but close to 12, right? 12 sprinklers you need.
Okay.
Okay, so that mean when you go for hydraulic sorry, when you do the hydraulic calculation, okay, when you see the total coverage area, you have to cover 1500 square feet. If there is anything fire in the light hazard, okay, so that means your coverage should be 1500 square feet. You have to cover.
Sir,
Okay,
once more.
okay. What I'm saying,
Okay.
example, you take that light hazard.
Okay.
Okay, so light hazard, how much coverage you should be? Total 1500 square feet. That is the minimum coverage, right?
Okay. Yeah.
Okay, one sprinkler, how much it can cover? 130 square feet.
130 square feet. Okay.
Yeah, so
Okay.
it is what given here.
We will get
Okay,
the total sprinkler.
so total number of sprinklers. So that means whenever you design the calculation, you have to cover 12 sprinkler. So 12 sprinkler will cover your 1500 square feet operation, sprinkler operation.
Okay. Okay.
Okay, so now you know that 12 square feet, you know the 12 number of sprinklers to cover that area. So now you know the each sprinkler. We have to calculate now each sprinkler what is the flow rate. Okay,
Okay.
okay. Now for example, I'm going to draw one area. Okay, I'm going to make a sprinkler layout.
Okay.
Okay, let me take one plain space. Okay, for example, if I go to take one plain area here. Okay, now this is my piping, main piping. Remember, we have seen that feed pipe, cross pipe, branch pipe. So
Yeah.
this is the feed pipe, and assume that this is a riser. So I'm just making a rectangle because this is a circle. Okay, assume that this is a circle, and I'm taking a one feed pipe, and the cross pipe will be how it will be cross pipe. Remember, there is a branch pipe and the
Yeah.
cross. This is the cross pipe.
Vertically.
Yeah,
Pipe.
vertical pipe. Okay, so this will be the feed pipe. So this feed pipe is what? This one,
Okay.
and this is a riser, and this is a cross pipe, and this is a branch pipe. Okay, so when I take the branch pipe, okay, for example, I'm going to take the branch pipe here. Okay, so remember, as per the sprinkler calculation, we are going to have a maximum of 8 in
8
one
for
branch.
extra hazard.
In one branch,
Okay. Number
no,
of
one
sprinkler.
branch, number of sprinklers should be 8 number. So
Mm.
that one we have seen somewhere back. Okay, I think you remember, right?
Yeah, I remember it.
Okay, now you take one total 8 number sprinklers, and here you have 8 numbers, and here you have again you have a sprinkler, then you have a branch here, then you have a branch, you have a branch here. Okay, so each and every line you will have a 8 number of sprinklers, 8 number of sprinklers, right?
Yeah.
Okay, now what is the distance between two sprinkler?
4.6 meter
Yeah, 4.6 meter. Okay, so
for
that
the
means
light hazard.
yeah, for the light hazard, and for the ordinary hazard also 4.6 meter, and for extra hazard it should be 3.7 meter.
Okay.
Clear now? You got that how
Yeah.
to make a layout?
Yeah. Yes.
Okay, so this will be continued for the every project. Okay, now for example, whenever you take one room, okay, remember when you have to go with the additional, say for example, I have a very bigger room, okay, and maybe you might have seen that I have a two riser pipe, two feed pipe. So when I will go with the two feed pipe,
If the area exceeds this 5,000 square feet.
no, that is not the correct answer.
Maximum sprinkler spacing 8
Yeah,
numbers.
maximum sprinkler spacing, right? So when I have a 8 numbers here, and when I have a 8 numbers here, I cannot go more than that, right? If I go more than that, I have some conditions. I have to increase little bit pipe sizes. So maximum I can go with up to 10 numbers of sprinklers. So if I go to more than area, then I have to have additional branch. Then I have to have an additional branch line here, right?
Yes.
Okay, so this is the way you can go on, keep on doing the zoning here. Okay. Okay. Now another one. Remember that area. How much area I can cover for one area? 4,830 square meter will be connected with one zone control valve.
Sound control valve. Yeah.
Okay, and also one alarm check valve. Okay. So if you have alarm check valve, that is sufficient for this particular zone. Okay, but this zone control valve, what is the purpose? When you have a multiple zones, multiple floor, to identify which zone you have a fire.
Yeah.
Clear, right?
Yeah. Clear.
Okay, now you can keep on doing the pipe sizing here. Now how you'll do the pipe sizing? Remember we have one table here.
Yeah.
You might have seen that depends upon number of sprinklers.
Mm-mm. From the UI fire code.
Yeah, UEFI code also there, and in UAE code also there. Sorry, in
NFPA.
NFP also it is there. If you go further down, yeah. Can you see this one? You can see this is for ordinary assault. Okay.
Mm-mm.
Normally we have a steel pipe and a copper pipe. There are two pipes they have given here, but the copper pipe will be very costly. That that one. So normally what pipe
Mm-mm.
they are using? They are using stainless. Sorry, the steel pipes, right? Galvanized steel pipe or black steel pipe. They use that number of pipes. Okay, that pipe material.
Okay.
So when you see here two sprinkler, you can go up to 25 mm.
Hmm.
Okay, and for
Yeah.
three sprinkler, five pipes.
32. 32 mm. 3
Yeah,
sprinkler.
yeah, three sprinkler up to 32, and
Mm-mm.
for five sprinkler up to 40 mm. Okay,
This
so
coverage, for example, if we have a double height area, how it will be? Like 4.6 meter between each sprinkler, right? If the height is more, we have to give additional or what?
no, no, that doesn't. That I will come back to you next one. Okay, what is
Mm-mm.
the coverage height? Okay, that maybe
Mm-mm.
they will go with the side sprinkler if the height is more than that. Okay, that we will come back to you that one. Okay, but now
Mm-mm.
we will talk
Okay.
about the sprinkler calculation, area of the sprinkler calculation.
Mm-mm. Okay.
Okay, if you have a very large height, that will be that it will change your type of methods. But now we are talking about for light hazard and ordinary hazard, not for special applications.
Mm-mm. We have retail here, and retail above fall ceiling we are doing piping, and below we are just providing one zone control valve, and maybe the client will provide later or something
No,
like
no,
that.
no, no. You mean above the false ceiling you are going to provide one sprinkler
Yeah, above
above
the
the
fall
false ceiling?
ceiling. Yeah, we done already the false sprinkler network, and
Okay.
we provide one more branch for the tenant to do the, because it's height area. I think it's
No, no, no. Yeah, that is understand. See, what I'm saying, there is a if your height is more than 800 mm, okay, distance between your false ceiling to the slab, if it is more than 800 mm, then you will be adding another sprinkler to protect the area above the false ceiling.
okay.
Okay, so that we will first we will do this calculation, then I will explain you for that part.
Okay. Okay.
Okay, so now you understand the steps.
Yes, yes.
First, you have to find out what is the type of assault, right?
Yeah. First type of sort, yes.
Yeah, first you have to calculate type of assault. Okay, that is the first one. Okay, then after that, uh, you will see that operation sprinkler operations, how much sprinkler operation, then hazard. Okay, and each sprinkler, what is the coverage area,
Okay.
right?
Yeah.
Okay, then after that, what is the distance between the sprinkler?
Yeah.
Okay, and you will calculate the number of sprinklers calculation.
Okay.
Okay, clear? So this is the step.
Yeah.
This is the step for you to do the layouts, basically.
Okay.
Okay. Now we will come back to the calculation part. So we will calculate each and every sprinkler. What is the flow rate?
Okay.
Correct. Okay. So that one you have a calculation. How to calculate the sprinkler flow rate calculation. Okay. Let me open. Okay. Sorry. I will repeat the steps again. So first you will calculate the hazard classification. Can you note down the steps to prepare the calculation? First one, hazard classification.
1 second, I will not know.
Yeah,
So, yeah. First, just step on.
hazard classification.
Okay.
Okay, next one, sprinkler protection area.
Sprinkler protection area.
Okay. The next one, design density. What is the density for ordinary hazard?
Design density 0.1. No, point ordinary hazard 0.15.
0.15, right?
Mm-mm.
Okay. Next one, K factor.
Step for K factor. Okay. Okay.
Okay. Okay. Next one, number of sprinklers. How you calculate number of sprinkler?
Number of sprinkler. First we have to take the area and divide by one sprinkler area. One sprinkler will be how much? 130 square feet, right? So total
Yeah.
area divided by 130 will get the sprinkler number.
So how much can you explain me?
Yeah, for example, if you have 5,000 square feet, so one spring
No,
5,000
no, no,
divided
no, no,
by
no. Will not go 5,000 square feet. That is a different. What is the coverage area? How much you have to cover for the light hazard? You have to cover only 1,500 square meter. Even though 5,000
uh,
square meter, even though 10,000 square meter, what is your design protection area? See, for example, if I have a building, if I have a building, big building, okay, I
okay.
have a number of, I have a feed pipe here. I'll be having a feed pipe, you can say. Then I have a branch, okay. I have multiple branches, for example, okay. Then
Mm-mm.
I have a sprinkler, I have a sprinkler, I have a sprinkler, everything, okay. But what is my basis of design? I will be protecting 1500 square feet only. That's it. I'm not going to calculate for
Mm.
the entire floor.
Okay.
Okay, if I have a fire here, I will be protecting only 1500 square feet only. I will not be protecting all the area. Because what is the purpose of this fire protection system? First of all, to save the occupancy. Second one, to save the building. Okay. If there is any
Mm.
fire here, only this sprinkler can suppress the fire.
Okay. Mm-mm.
Okay. Or it can protect from fire. It doesn't mean that I have to spray all the area. That means if I have to spray all the area means what is the meaning? That means the fire
Mm-mm.
spreaded to everywhere. So that means the fire is apart from my system. Okay, so which I cannot protect from, through my system. So what is purpose of the system? In case if there is any fire here, I have to protect this area. So what is the protection area?
Okay.
1,500 square feet.
This is
That
only
is the
for light hazard.
density. Light
Light
hazard
hazard
and
only.
ordinary hazard also 1,500.
Okay. Mm-mm.
And ordinary hazard 2 also 1,500, right?
Yeah. I need to check that graph.
Yes, that graph if you go further down, so you can see that the sprinkler discharge pattern, how it is pattern discharge, right?
Mm-mm. So what I understood is if you have a huge area, we have to in light hazard 1,500 we have to consider.
1,500
1,500,
only. Yeah, 1,500, not more
1,500
than that.
12 sprinkler like that we have to decide.
Yes,
Mm,
yes, yes, yes. Okay.
mm, mm, mm.
Okay. What is the density here? For light hazard, 1,500 square meter. Ordinary hazard 1, 1,500 square meter. Ordinary hazard 2, 1,500 square meter. But the density will change.
Yeah.
Okay, so if you talk about extra assert, it will be zero point 0.3, but it will start from 2,500 square feet.
Okay. So extra hazard area we have to consider 2,500 square feet
Yes, yes,
divided
yes,
by the sprinkler coverage area.
yes,
Okay.
yes. Now, how to calculate
Okay.
the flow rate of the each sprinkler? How you calculate?
Flow
That is
rate
there is
this multiply by area into density.
no, that is not, that is the area, that is the protection area only.
No, the GPM will get density multiply by area will get the GPM, right?
You mean 1,000? For example, 1,500 multiplied by
0.1.
Yeah, 0.15 or 0.2500 multiplied by 0.15. Yeah, you will get the GPM, which is
Uh,
230, 225 GPM, right?
yeah. Mm-mm.
Okay, so this is basically based on these equations. Okay, but now we are going to calculate based on the K factor.
Okay. Mm.
Okay, so if you go through this particular document, there will be equation. Let me check the equation here. Yeah, so here also you can see the sprinkler maximum pipe, minimum pipe sizes also given
Mm-mm.
here. Okay,
Here only up to 6 inch only they given. More
yeah,
than
yeah,
6 inch.
yeah, you can go to NFPA.
Mm-mm.
And also you can see the light assault, see the based on the density graph.
Oh, okay.
So
Mm-mm.
that table also given here, area of operation, water demand. So remember just now we calculate 0.15 equal
Mm-mm.
1500, it will give you 225 GPM. So this is the water demand for the particular area, for the sprinkler only. Okay,
Okay.
only for the sprinkler it
Mm-mm.
is 225. Okay. So in the system, what are the three systems we have? One is the sprinkler, another one is the fire hose cabinet, and another one is the fire hydrant, right?
Standpipe. Oh, yes.
Yeah. So that means we have to calculate internal or external, which is higher.
Mm.
Okay, internal or external, which is higher.
That means
So
sprinkler or
so
fire hydrant.
sprinkler plus fire hose
Fire hose
cabinet,
cabinet
or
or
you
fire
have to
hydrant.
calculate what is a fire hydrant. Okay. So now if we calculated a sprinkler, just
Yeah.
assume that we calculated for sprinkler. How we calculate? 1500
H1.
multiplied by the uh, different assert, and then you calculate the total flow rate. Okay. So here also you can see
Okay.
the protection area S by L. The sprinkler zoning and area limitation will be 483 sound square meter for each and every alarm check valve.
Yeah.
The maximum area also should be protected by 4831 square meter only. Okay, the maximum floor area. Otherwise, you have to have a multiple zone control valve with a common alarm check valve. Okay,
This alarm check well also limitations, right?
yeah,
Maximum
limitation is that. Yes, yes, 4831 square meter in sprinkler zone.
4831 or
Yeah, 4831 square meter.
for one alarm check well.
Yeah, for
No.
one alarm check valve. Yes, yes, yes.
No. Then sound controller both are same.
See, alarm check valve you can provide only one. Okay, for the common for the total building for the sprinkler,
Oh.
and you can add zone control valve each 4831 square meter. So that means whenever you have a sprinkler line from this is from your discharge from the pump, okay,
Mm. Mm.
and you can provide one riser, then
Yeah.
you can provide one alarm check valve, and whenever you have a zone control valve, this zone control valve will cover either one floor per floor, or one zone control valve can cover up to 4831 square meter. Then you can add multiple zone control valve.
Okay. So
Clear,
only
right?
one alarm check well is required on
Yeah,
the
yeah.
discharge side.
Yes, yes, yes. Discharge side. So from the alarm check valve, you are going to provide multiple zone control valve which will cover 4831 square meter. Either should be per floor or should be maximum of 4831 square meter. In that particular floor, you have a more than 4831 square meter, then you add two zone control valve in that particular floor.
Mm-mm. Okay. Mm-mm.
Okay, I'm not getting that equation, but it is somewhere there. Let me tell you what is the equation. Okay.
This K factor, and if you multiply this density into area, we are getting the GPM, right?
Yeah,
From K
that is
factor is also
okay.
using
But there is a
K
pressure drop,
factor.
right? There is a pressure drop.
Mm-mm. Mm-mm. Okay.
See, now for example, this is your pipe. Okay. Okay. Now this is your sprinkler, right?
Okay.
Okay. But when my pump is there, this pump I will be supplying 225, right? For example, I
Okay.
have a pump. I have a
Mm-mm.
pump. I have multiple sprinkler. For example,
Mm.
okay, 12. Assume that I have a 12 sprinkler.
Okay.
Okay. Now, if you see my pump, I'm going to design my pump for how much GPM? 225 GPM, right?
Okay.
But do you think that the 225 GPM will reach at this particular area after having a pressure drop of pipe and sprinkler?
Oh no. Okay.
No. Okay. So
Mm.
that is what I'm going to calculate pressure drop calculation for sprinkler. So this is the hydraulic calculation. Okay, if I do as
Okay.
per pipe sizing method, I will say yes, 225 GPM is okay for the light hazard or for ordinary hazard to protect my spaces. Okay, but
Okay.
there is a calculation, there is a pressure drop calculation that is based on, uh, I think that
Darcy-Weber equation.
Darcy Weisbach formula. Okay,
Mm.
that is based on the K value.
Yeah.
Yeah, yes, I got this one. Okay, now can you see this particular value here? Q equal K multiplied by square root of bar. Okay, and I know the flow rate. For example, I'm going to calculate the flow rate here, and I know what is the K value. K value is 5.6, right?
Yeah.
Okay, and each sprinkler will have a pressure drop. Each sprinkler.
Mm.
So that is also I will get it from here in this NFPA. Okay, can you see this value here? Uh, the minimum pressure drop of any sprinkler shall be 7 psi or zero point 0.5 bar, right?
Minimum operating pressure of any sprinkler should be minimum operating pressure.
Mm-hmm.
Okay.
Yeah, let me check my. I did one small pressure drop calculation. Just now we calculate how many GPM? 225 GPM, right?
Yeah,
Okay. Can you divide by number of sprinklers?
18.75. No,
8.
GPM divided by number of
No, no.
sprinkler.
GPM divided by number of sprinklers. That means 225 or 250.
Now we calculate 225. 225 divided by 12 means 18.75.
Okay. So that means approximate 19, right?
Yeah,
Per sprinkler. Okay.
yes,
So you
right.
know the flow rate, Q, you know. Okay.
Mm-mm.
Yeah, Q, you know. Then after that, you know the K value, you know,
Root of
for 5.6.
Q is equal to K root P.
Okay. See, I have just opened one my previous document. So basically, the hazard classification is the first one, and area coverage by sprinkler is say for example 130 square feet, and the density will be 0.15 GPM per square feet. So the total area protection will be 1500 square feet, and the K factor 5.6. Now this is a residual pressure. Residual pressure is 7 psi. Okay.
Okay,
Okay, then the Hazen-William equation we will apply. So what is the Hazen-William equation? P equal to 4.5 to Q multiplied by power of 1.85 divided by C by D. Okay. So what is the
mm,
formula to calculate your K value? K is nothing but Q divided by square root of delta P.
okay. Mm-mm. I
Okay, so
can't
K
see
value
your
we
screen.
know. No, no, that I'm just checking my other documents.
Okay.
So K is nothing but 5.6 and uh,
Okay. So residual pressure is 7
okay,
psi, minimum
yeah,
operating
yeah.
pressure.
So the residual pressure will be let me check if there anywhere they have given the minimum pressure I have to achieve in the sprinkler.
Okay.
Okay, I got 12.3 psi.